Our last lesson on compound inequalities is OR compound inequalities. Alright, our objective in this video, or this lesson, is to write, solve, and graph OR compound inequalities. Alright, this is your vocabulary about an OR compound inequality. And basically an OR compound inequality is a union of two sets. So review what a union of two sets is. Alright, when we solved AND compound inequalities, we were looking for values that made both inequalities true. In an OR compound inequality, we're looking for values that will make either compound inequality true. And here's an example of what it looks to be an OR compound inequality. So review that and pause the video if you need to get this information down. Alright, we're going to begin our first example of an OR compound inequality, and I'm going to start out with the basics. We already have a compound inequality that's already solved. W is greater than 7 or W is less than -3. And we're going to begin with graphing. Alright, we're going to start out just like we did with the AND compound inequality. First, we're going to graph our first inequality on a number line. So greater than means open dot at 7, and we shade all the way to the right, the way our inequality points. And on our second inequality, we're going to have a closed dot. That's our starting point on W is less than or equal to -3. And since our inequality is an arrow that points in the direction we shade all the way to the left. Next, I'm going to take those two inequalities and create the graph of our OR. In an OR compound inequality, what we do is we take everything that is shaded on either our first graph or our second graph, and we shade it on our second graph. So if you look right here between -3 and our arrow, it's shaded and there's a closed dot. So we have to put shaded and a closed dot. If you look between the -3 and 7, there's nothing, so we don't shade there. And if you look at our two number lines, we have an open dot at 7, and it's not circled in, and 7's not shaded on the second one, so we don't shade it here. But we do shade to the right. And that's the graph of this OR compound inequality. Now we're going to write the interval notation, and the interval notation, if you remember from before, we put -infinity to the left, +infinity to the right, and our interval notation is to start point, comma, stop point on our shading. So we're going to read from left to right, and our shading starts at -infinity, and it goes to -3, and then it stops. But it starts up again at 7 and goes on to the arrow, which is +infinity. Alright, now this interval notation is a little bit different. Remember, you have parentheses everywhere that you have anything but a closed circle, and at 3 I have a closed circle, so it's a bracket. But then we've got to join these two by the symbol for OR, which is the union symbol from your vocabulary. And finally, set builder notation. Brackets. So remember, our brackets stand for all real numbers, and the variable we're using, which is W, and our slash, which means such that, and then we just rewrite our inequalities. And instead of the word OR here, you can use the union symbol again. And that's how you graph a compound inequality with OR and write it in set builder and interval notation. Alright, this is our first example here where you're going to solve a graph and write it in the compound inequality or in set builder or interval notation. First of all, though, there is a slight typo here. I want you to mark out that 11 and make it 10. So solve each inequality, first the first one, then the second one, then take your two answers and put the word OR between them. And you'll recheck your answer once you're done. So pause and see if you can work this out yourself now. Alright, here's the answer I got. I got W is greater than 1 or W is less than -3. Now let's see if you can take what you learned just a minute ago about graphing an organic compound inequality and graph it yourself. So pause the video now and try to graph it. Alright, here's what I got for my graph. I hope you got the same thing. Remember what your final graph is on an OR compound inequality is just everything shaded on your first solution plus everything shaded for your second. Has to be shaded on your final answer. Now use that information and see if you can come up with your interval and set builder notation. Remember, interval notation is just shading, reading from left to right. Where it starts shading, comma, where it stops shading. So try those two now. Alright, here's my interval and set builder notation. Hopefully ours are the same. If not, make sure you ask and we'll talk about it tomorrow. Onward to the next slide. Alright, here's our next example. I want you to do the same thing that you did before on the previous video. So start with solving the inequalities. So pause the video and do that now. Alright, two things I hope you noticed in solving these inequalities. First of all, in the first inequality, when I solved it, I actually did not have it in my format that I want my inequalities written. It was number inequality variable, so I had to switch those two. And when I switch those two, I have to switch my inequality to make it accurate. And in the second inequality, I had to divide by a negative number. Remember, when you're solving an inequality, if you multiply or divide by a negative number, you have to flip the direction of the inequality. Alright, now try your graph and see, and once you get that done, restart the video and check your answer. Alright, so here's what my final graph looks like. It looks like a little bit different than the last two examples because if you compare our two solutions, our graphs of our two inequalities, solutions of the inequalities, you'll notice that the first one has shading at 1 and goes over to negative infinity, and the second one starts at 2 and has shading over to negative infinity also. And remember, we have to, anything that's shaded on either one of these right here has to be shaded on our number line. So it starts our shading at negative infinity and goes up to 2. Now try your interval notation and your set builder notation and restart the video to check your answer when you've got them. Alright, so here's my interval notation and here's my set builder notation. You'll notice, remember, interval notation is just shading on the number line from start point of the shading to stop point, and we only have one start point this time at negative infinity and one stop point at 2, and 2 has a closed dot, so we have to use a bracket. And since we only have in our set builder notation one inequality, because our x is less than or equal to 2 covers our other solution, x is less than or equal to 1, so we only have to write down the x is less than or equal to 2. Alright, here's one for you to try. Why don't you work this one all the way through? Solve your inequalities, get your graph, your interval notation, and your set builder notation all at once, and then check your answer. So let's stop the video now and go ahead and you try this one on your own. Alright, here's my answer. You'll notice I have an open dot at -1 because it's x is less than -1. It doesn't have the or equal to, and a closed dot at 3 because it has the or equal to. And when I wrote my interval notation, I put parentheses everywhere except for where there was a closed dot, which was at 3. I put a bracket. Alright, let's go on to the next example. Alright, this is a more challenging one for you to solve. It actually has a variable on each side. So remember, how do you solve an equation with a variable on each side? So let's solve each inequality and then let's check your answer before you go on to the graph. So let's start solving. So stop the video now. All right, I hope you remember that when you solve an equation or inequality that has a variable on each side, for it to be solved, you have to have all your variables on one side by themselves. So this is the answer you should have got. And another thing to take note of, in the second inequality, I had to divide by -3. And when I divide by -3, when I multiply or divide by a negative number, I have to flip the direction of my inequality. Now let's check and see what you can come up with graph. So pause the video and try your graph. Alright, here's the graph I got. Now, let's use the graph to create the interval notation and the set builder notation. So pause the video, do that now, and restart when you're ready to check. Alright, here's my interval and set builder notation. I hope ours match. On to the last slide. Alright, let's see, can you do this? Can you write a compound inequality that represents the following statement? The product of -5 and a number is greater than 35 or less than 10. Think about it, see what you can come up with, and we'll talk about it in class.